everyone and welcome to a new video. Federico here in sort of heavy metal version because I wash my hair and I cannot be bothered with drying them, and this is just too boring, and I'm not the only one out there that doesn't like to dry his hair. Only problem is that we're gonna be sick. People, just accept it and everything will be fine. Anyway, in this video we are going to talk about the family of path objects. So what do we got? We got the jit.path, we got the jit.gl.path and the jit.anim.path. So we're going to see how we can use those objects and how we can create this sort of roller coaster path inside my amazing Max Stuff amusement park. The cool thing is that we can also attach a camera to this path, which is super cool and already makes me a bit dizzy. I always hated roller coasters, although this I guess is pretty safe. Yeah, that's pretty cool. So before we actually start, while you are cruising in, will be very appreciated if you will put a like to the video, subscribe to the channel, or maybe just put a like after you watched it if you really liked the video. I guess this makes more sense. And if you did, yeah, subscribe to the channel will be also much appreciated. So without any further ado, let's start. So I have deleted from the patch everything that was related to the path objects, and we can start from kind of scratch. So we're just left with the basic scene, which consists into a bunch of geometry, a bunch of cubes that are scaled and positioned in the scene at random position. Then we have this 3D text which says Amazing Max Stuff Park. And since its color, so if we check here inside the scene sub patch, since its color is beyond the value 1, it will be intercepted by the jit.gl.path bloom HQ, which has a threshold of 1.1. So all the colors that are above the value 1.1 or equal to 1.1 will be taken into account by this effect, which will make the bloom effect. So that's why the name of the park is blooming. Then we got a skybox, which is also inside the piece scene. And we have a GGL environment, which contains the environment map as an EXR file. This is a built-in file inside Max, so you can use that as well. It's called Photo Studio Loft Hole 2K. And then we have a floor, which is represented by a grid shape. And we have the GGL PBR attached both to the floor and to the cubes, to these structures coming out of the floor. So this makes them use the environment map to affect their color and what they reflect. So that's pretty cool. So the scene, in this way, the scene looks pretty nice. Also have a GGL light with shadows activated, shadow quality high, medium high, and shadow blur set to 0.05 in order to not have the shadows too blurry, but sort of kind of focused. And that's it. The last thing is remained here, it's a camera, which is connected to a jit.anim drive. So we can move around in the scene pressing the WASDQZ keys. Good, so let's start now to work with paths. Now let's say that we have a geometry that we want to move around in our scene following a precise path. So let's say, for example, a sphere. Cool, so let me create a sphere. There she is. And I will also connect it to a GGL PBR to give it a material, and I will set the matte diffuse to red, so it will have a nice red color. This GGL PBR will also use the environment map, so the sphere will look pretty juicy. As we can see, it looks pretty nice. As we can see, it's reflecting the windows from the room where the light comes in, and this is kind of really cool. All right. So then, to animate the sphere along a path object, we can use the jit.anim.path object. Oop, wrote it wrong. Jit.anim.path object. Now the path objects are all kind of the same object in 3 different flavors, because we have the jit.path object, and then we have the jit.gl.path object. Now the jit.gl.path is actually something a bit different, because this is what we use when we want to render a path. But all of them more or less share the same attributes, like they all have an interpolation mode, which could be linear or spline, for example. They all accept a matrix to set the path, and they all accept messages to edit their points, their path. So they're all kind of the same object in 3 different flavors. Now for the moment, we're going to use the jit.anim.path and the jit.gl.path. So the jit.anim.path will have an attribute called drawPath, and for this attribute we need the name of a jit.gl.path. So this anim.path object will draw as a geometry using the name the jit.gl.path. So if we say drawPath, and let's call it my GL.path or something, and then to this jit.gl.path object we give it the name my GL.path, right? So now when we set a path for this jit.anim.path, we will be drawn by this jit.gl.path object. Cool. So let's give it a go, and if we check the help file of the jit.anim.path object, we can see that we can set points for this path by using the append message. And the first number is going to be the time that the animation will take to go from one point to the next one. So for example, to arrive at the first point, it will take 0 seconds, because we will start somewhere, so we don't need to have a pre-delay. And then we have 1 second, this is in seconds, to arrive to the second point, and so on. So if we say here, append 0, and let's start, for example, with an x of -10, an y of 0, and a z value of 10, for example. And then from here, let's create a second point, and this we'll get there in 3 seconds, and this is going to be a 10 on the x, 0 on the y, 10 on the z. So if we connect this here and bang this message, we see that nothing happens, because the jit.anim.path, in order to work, it needs to be connected to a GL object. Otherwise, the anim objects don't work unless they are connected to a GL object. So let's connect it to our GL grid shape. But actually, let's do like this. Let's create a jit.anim node object. So this will be the object responsible for the transformations of our GL grid shape. And let's give it a name, and let's call it like a shape node or something. Connect it to this GL grid shape. And then to the jit.anim.path, we can give it a target name, which is the target for the animation. And we will call it shape node. Alright, so now if we send this append message with the 2 points, we see that path has been drawn in our world, because the jit.anim.path is now connected to this jit.anim node, so it's kind of active. The path is represented as a thin line, so we can change that by changing the path style, and for example, a nice one, it's called tube. But this tube is pretty fat, so we can actually change its radius by using the extrude scale attribute, and we can set it to something like 0.1, 0.1. And maybe this is even too thin. Let's change it to 0.2, 0.2. Okay, that is a bit more consistent. Nice. And we can attach as well a GGL PBR to it. Let's maybe not set the matte diffuse. Let's leave it white, and let's connect it to the GGL path. And nice, now our path is also reflecting the light from the scene, which is something that I really love so much. So cool, we managed to draw our path. Let's actually give a color to the path, to the GGL path object, so we remember this is the GGL path. All right. So I want to modify now the second point, but before I do that, we can send the clear message first to the jit.anim.path, so it will clear the current path. And then we can start append again points, otherwise it will create overlapping paths, let's say. So let's say that we want this to go to -10, this second point. So exactly, this will be something like that. But let's put another point in the middle, and so let's say append, and we get 2 seconds to get there, let's say. And this is going to be at -15, 3 in height, or let's say 5 in height, and also -10 on the z-axis. So let's do this, and that's our second point. Let's create our fourth point, and we could actually use a call to store our points. So let's actually do that. Instead of having a very long message, it's actually better. I find it better to use a collection for that. So let's double click on our call. Let's give it embed one, so it will be saved. The content of the call will be saved with the patch. Double click here. And let's say the first point, let's write them from scratch again. So it will take 0 seconds because it's our first point. And it will go to 10 for the minus 10 for the x, 0 for the y, 10 for the zeta. This is where we start. The second point, we will get there in 3 seconds. It will be a 15 for the x, 5 for the y. And let's say again 10 for the z, or 12, 13 for the z, doesn't really matter. And then let's have another one, which will take 2 seconds to get there. And this is at minus. So let me see, I'm kind of lost in my scene. So minus x will be this direction. This is our z, so let's actually set this to minus 13, then we will want to go here. We want to go here to minus 10 again on the x, 3 on the y, and I don't know, 10, 13 on 14 on the zeta, and then another point. Third point, we're going to take 1 second to get there. This is at, I don't know, 5 on the x. Now I'm just really writing random numbers. 0 on the y, and kind of minus 10 on the z. Okay, cool. Let's close this window and validate it. Cool. So here we can say prepend append. So we're going to put append and then this message. Connect it here. And if we send the dump message to the collection, we will send all the messages at once. So we will append, and then followed by our message. So if we check that, you can see that this printing append followed by our messages, our points data. Though before doing that, we said we first want to clear our jit.anim.path, so we can do like this. We can use a trigger object to first clear and then send the messages. Okay, so it will first clear and then send the messages. Let's give it a try. And ooh, it looks like the point I've chosen are really bad, actually. Looks like a mess. Okay, so let me check what I've done. First, minus 10 on the x, 0 and 10 on the zeta. Second shall be 15 on the x. So yeah, we go all the way to the other side. Let's actually keep it at minus 15 and then these at 10 and these at 5. Let's try like this. And okay, doesn't look too bad. I mean, it's a bit strange, like a Z, but it's okay. We're going to work with that. And then let's do one thing. We can, as you can see now, between one point and the other is just doing a kind of a linear interpolation. Is arriving to that point, then going to the other point, just in very sharp angles. It's not doing any sort of interpolation, basically. So we can set the interp mode to spline. In this way, it will use a spline curve for the angles instead of just doing zigzag. Cool. And then we can even close this path if we chose to. So for example, here the call will send a bang when it finishes emitting the data from the dump. So we can send them the message close path. And this will close the last point. This will connect the last point with the first point. So yeah, we have a nice 8 shape. Cool. So nice. What we want to do now, we are ready to animate our shape according to the path. So what we can do is to send the start message to the jit.anim.path object, and let's see what happens. Cool, our shape is following the path, and it's taking the time that we said to arrive from one point to the other. And then it's going on and on again, because by default the path is going to loop. Nice. So let's stop that. And you know what? We can also attach a camera to a path, so the camera will actually follow the path, which is something pretty cool. So let's do like this. Let's create a GGL camera. Let's just give it the attribute tripod 1. And there she is. And we actually need to disable our other camera, otherwise we will see the view from both of them, which is a bit awkward. So I connected here this receive edit mode to an enable message to our camera. So if we make here a toggle and say send edit mode, right, this is how I called it, yeah. So if edit mode is on, it means we see the world as we were seeing it before, our scene. But if edit mode is off, it means we want to enable this other camera. So let's give it by default an enable 0 attribute. And let's say here, and here we can just create a prepend enable object. And then if we say 1 minus that, minus the value of edit mode, we will have that this is active when the other is disabled. So if we go in edit mode, we see that. If we go in kind of fun mode, then we see the other camera. Cool. So let's create another node now, another jit.anim node. Let's give it as a name camera node. Connect it to our camera. And now we can change basically that as a target name for our jit.anim.path. We can either use camera node or we can use the shape node. Okay, so let's connect them both here. So if we use camera node as a target and we start that, that's pretty funny. We are looking inside the path. So let's actually maybe disable the actual jit.gl.path object, because otherwise we are just going to see inside the tube. So let's actually connect it to edit mode. So when edit mode is on, this is visible. When edit mode is off, this is not visible. Cool. So our camera is now following the path and it looks a bit like a roller coaster, right? It's actually pretty fun. But if you look at this, you can see that it's actually always looking in the same direction. Our camera is looking in the same direction. In fact, if we go into edit mode and give it as a target the shape node, and we transform the shape into a cube, you can see that the cube is always facing the same angle, right? So it will be cool if the shape would always orient itself in the direction of the path. That will be cool, in the direction of its velocity, basically. That will be real cool. So to do that, we can take the position that the jit.anim.path says the object should have at this frame and subtract the position from the previous frame to the current position. And this will give us a vector that goes exactly in the direction of motion. So if we check what's coming out of jit.anim.path, we can see that it's actually the position of the object at this frame. So if we do a root position, we get the position for this frame. And then we can use a backsp object and subtract the input 2 from the input 1s. And then we create a trigger list. So the first output will go into the hot inlet. So this will be our current. This will be our current position. And the second outlet will go into the second outlet of the backsp object. So what happens? That at this frame, we will subtract the input 1 with whatever was inside the input 2, which will be the position from the previous frame. Very cool. And this will give us the direction. So the jit.anim node has an attribute called direction, which is the direction in which our object should look. So if we connect this to our anim nodes, let's send it with a send object to our anim nodes. We can receive it here to both our anim nodes. Now you can see that our cube is actually always looking in the direction of the motion, which is really cool. So let's connect it also to our camera. Yeah, you can see that the cube is always looking in the direction of the motion. If we will give to this anim node the tripod attribute, I guess our cube will always stay exactly horizontal. and will never kind of tilt. So this is if you need it to tilt according to the path, you can leave tripod off. But if you want it to never tilt, so like really be like a roller coaster wagon, then you will give it the tripod 1 attribute. Cool. So let's change now into fun mode, and we can see that our camera, it's okay. We need to change the camera node here. Woo. And as you can see, the camera is not really using the tripod. So let's go into the anim node and say tripod 1. Yeah, otherwise we get really sick. Cool. It really looks like a roller coaster or something. It actually makes me a bit dizzy. But the camera is following the path and always looking in the direction of the path, which is really cool. I never really used the path objects, but this is extremely funny. And it's so powerful. They're such powerful objects. Nice. So let's go back into edit mode. And one thing that remains to be... Oh, you know what? We can also automate that when we change to edit mode, we will use then the shape as a target. Otherwise, we will use the camera. So let's do like this. Receive edit mode here. Select 1 or 0. And if it's 1, we are going to use the shape node. And if it's 0, we are going to use the camera node. Right? Yes. Okay. Cool. So one thing remains to be done, which is we could actually not be satisfied with our path how it is, and we have a possibility to change it manually, let's say, by modifying the single points or modifying the handles. So if we go into the help file of the jit.path object, we can see that if we go into the editing tab, there is this two kind of little systems that allow us to modify the points and the handles for the spline curve. So if we send the get point message, we will have the current point that we set. And if we send the get handle, we will have the current handle at that point. So let's take a look at what this means. If we go inside the jit.gl.path here and we say draw handles 1, this object will now draw the handles for the spline, and these handles is what decides basically the curve at that angle. So we can change that curve by modifying those handles. So sorry, let's go again inside the jit.path help file, and let's copy those two objects, the auto handles, we don't care. Let's close that, and let's paste them inside here. Starting to get a bit full of stuff this patch, but it's okay. So what we want to do is to get those values, and we can get the point and the handles out of the dump, out of the jit.anim.path. So cool. So if we now say the message, if we now use the message get point followed by an integer, which represents the point we want to get, the index at that point. So let's say that the first point, number 0, will be at -10, 0. There's actually, our first point is 0, -10, 0, 10. So actually what's going on is that the jit.anim.path, when we request for a point, will send out a lot of values. And the first one is actually the index of that point, and then followed by the time, and then followed by the position. So actually, we should also include the first point as the index, and this is not done inside here because I guess the jit.path doesn't give us the index when we request for a point. Right? Let's give it a look. So if you request a certain point, yeah, exactly, will just give us the time value followed by the position, but the jit.anim.path will give us also the index of that point. So we need to account for that. So inside here, pset point, we just want to add another float value here, or actually, yeah, float value for the time. And then we move them all one to the right. And the same thing we do into set handle. We add another float here for the time, and we move all these cables to one to the right. And here we need to add also another value. on this pack object, and we move them all again to the right, and the same thing we do here, in order to have that value for the index of the point. All right, so now if I get the point 0, exactly, we get exactly the position. We should be maybe also able to get the time at that point. So if we want to change also the time, we can do like this, prepend set. Let's get another outlet here. Let's get another float point. And let's see if we get the points, exactly. So we also get the time, which I guess we can then edit as well. So we can now send those lists to our jit.anim.path. The bank we don't really need actually. So we could have it as a trigger list and then connect this to the jit.anim.path. So cool, so now we are ready to change the points. For example, if I want to change the point 1, I can change it using those numbers here. Cool, so if I'm not satisfied with it, I can change it using that. And I can do the same with the handle. So if instead of get point, let's have to encapsulate some stuff. So let's call these target names, right? And then let's copy that and let's connect it to jit.anim.path, but this will call get handle, I think it's called. So if we now try to get the handle number 1, exactly, we should be able then to change the handle. But we cannot change it because there is actually an attribute that we need to uncheck in order for us to be able to modify the handles. And this is the attribute auto handles. And let's set it to 0 because by default it's on. Okay. So if we now redump all the points inside, you can see that the handles have not been calculated, so the spline is actually not working. So we need to send it the message calc handles after we send all the points. Otherwise, it will not do the splines. Okay, cool. So now it calculated, if we send this message, it calculates also the handles. So we have the curves, the spline curves. Good. And now we can modify those handles. So if I go here with this point and try to modify this handle, let's actually maybe move a bit the cube. Okay. So I can modify these points with these 3 numbers. So I can modify the handle, which basically means how the curve is going to look. And I can make it very wide. It's pretty cool. We can really get a lot out of that. Nice. And cool, so we found out how we can modify as well the handles for our path. Let's try to start it again. So you will see now the object will follow the new path with the new handles. If we go into fun mode, you can see the camera following the path. This is so much like a roller coaster. It's really cool. Okay, cool, but now you're probably asking yourself, okay, I can save the points inside the collector because they're embedded, but how can I change the handles which I've modified? And the solution is actually to use jit.path, because jit.path will output a matrix that contains the handles as well. So if we send the points and the handles as well to the jit.path, it will have the same path inside, and then we can output its matrix and save the matrix, and this will contain the handles. So let's do like this. Let's create a message and call it to.path or something. And we will send it our points here. We will send it the close path and the calc handles as well. And then we want to send it any modifications that we do to the handles. Cool. So let's receive these here. jit.path, right? Let's actually put it, I don't know, let's maybe put it here, down there. Cool. And let's check with the jit cell block what is actually going to output. So if we send it the points and then we output its matrix, we can see that it contains the points and the handles are on the second row. So the first row is going to be the points, And the second row is going to be the handles. Let me send it a plain -1 message so we can see all the numbers inside the single planes. And let's maybe make these cell block a bit bigger. So let's go here and make the space for each cell a bit bigger. So let's make it 110 or something. Oh, 120. Cool. And so we can see that the values for the handles are not really set. Oh, you know what? I forgot that we should also send the clear message to the path. So all these three messages, all these three cables must be connected also to the sender here. So if we now try to modify a handle here, let's see if this is reflected on the x-axis. So this will be reflected on the path as well. Oh, but actually, it's not using splines at the moment. That's why the other handles are all set to 0. So what we should do, and by the way, let me set a load bang here. What we should do is to actually set it as interp mode spline as well here. As I told you, these objects almost share, all of them basically share the same attributes. And then we can also set use time, so it knows that the first number in our point is going to be the time. So this should now make it in a way that our handles are already set by default. Okay, cool. Nice. And if we want to modify them, we can modify them. This will be reflected inside our jit.path, as you can see. And then we can save that in a jit matrix. We can output this matrix on the jit matrix. You know what, we should maybe just set here also a bang after it receives the list of stuff. So we're always sure that this jit matrix is always updated with the latest points. Exactly. And then we can send a write message to this jit matrix. For example, I want to write into the desktop, and this is a file jxf. I will call it my mat. So I just need to write here. And the matrix is saved on my desktop. Then when I open the patch again, I can read that matrix. And then I can send it somewhere. So let's say this is the points mat or something. And I will send it to the jit.anim.path. So let's do like this. Let's close this patch, open it again. There we go. Here is our scene. We should actually load mass the edit mode with 1. So we start in edit mode. And if I just dump the points as they were initially, I will have them like this, but I will have lost the handles. But if I read this matrix and then I actually bang it out, so we could add a bang after we read it. Cool. Now you can see that the path changed to my to the curve that I set before with the handle. So awesome, we found a way to store our paths, which is really cool. And this was basically it. There is probably some more things to know about paths that we haven't covered here, but it's probably going to be some minor things that you can figure out for yourself by knowing what you now know. Okay, this was it. Thanks a lot for following. If you want to download the patch, is up to grab on my Patreon for a little monthly fee. And this gives you also access to millions of other patches now. Okay, it's probably hundreds of them. And this gives you also access to my Discord community. So there's a lot of perks to be had on my Patreon. So maybe check it out if you like what you saw. Anyway, I will see you in the next video, hopefully. In the meantime, have fun. Ciao.